Welcome back students in Maths Classes channel for the maths related material. Today we are going to discuss about class 12 topic of application of derivative, increasing or decreasing function. How can we check increasing or decreasing function? When a function is given, there are two type of rules. First of all, we are going to discuss when a function is given, say fx on given interval, otherwise given on any set of number, how can we identify the given function is increasing or decreasing? There are two types. First type we are going to use here, first by without derivative, because the name of the chapter is our application of derivative. It means we have to use the derivatives here. First of all, we are going to discuss without use of derivative. How can we find out? How can we solve like this? First of all, we choose any two values from the given domain. We are taking here real number such that there is a relation between two values. We are taking here first value is less than second value. If we get the function at that point gives us same symbol, this is one of the possibility. Maybe we get this one, function at the indicated point but the symbol change. So these two type of possibility we may get here. If symbol remains same, it means function is increasing. Otherwise we can say strictly increasing. Same here, when the sign, it is less sign but it becomes reverse of it, so it is known as strictly decreasing function. This is the first method to check the given function is either increasing or decreasing here. Here we are taking here example, like the example is given by f of x is given by 2x plus 5 and the x belongs to real number. We have to check either it is increasing or decreasing here. If we choose here same case, let x1 x2 belongs to real number such that x1 less than x2, we are changing other. We are going to continue. How can we reach up to f of x1, f of x2? We are going to make first of all variable term. If we replace here f of x1, it should be of type twice of x1 plus 5. If we replace x2, it should be of type 2x2 plus 5. So first of all, we are going to make this one. By multiply by 2 on both sides, we get twice of x1, twice of x2. If two values are in comparison, if we make double of both sides, there is no change. Now we are going to add 5 on both sides, means equal values are given to both. It means no change, they remain their position. It is given by f of x1 and it is given by f of x2, as we have discussed here, f of x1 and f of x2. Here x1 is less than x2. At point x1, function is again remain less than. It means no change of sign. So these type of function are known as strictly increasing function. Another we also take here example on the other side. If the function is given by this one, f of x is given by 2 minus 3x, x belongs to real number. So what is the change here? We have to still take let x1, x2 belongs to real number such that x1 is less than x2. Now we have to change according to requirement. Here f of x1 become, it is given by 2 minus 3x1 and f of x2 become here 2 minus 3x2. Same trick we are going to use. First we get the x term. X term is 3 times. So multiply by 3 on both sides. We get 3x1 less than 3x2. Here sign of x is negative. When we operate negative sign, value symbol change. How it will work? See here example. 5 is greater than 3. If we apply minus symbol, what is the effect? Minus 3 is greater or minus 5 is greater? We know that smaller value negative are bigger. So this value change. Means when we apply negative on both sides, otherwise cancel out the negative on both sides, symbol between them change. That's why we change the symbol here. Now we have required 2. So adding 2 on both sides, we get 2 minus 3x1 greater than 2 minus 3x2. This is the value of function at x1. This is the value of function at x2. Means x1 is still on the left hand side, x2 is on the right hand side, but symbol change. So these type of function are known as strictly decreasing functions. So like this we can do by without use of derivative. We can identify given function is increasing or decreasing on the given domain. Now we are going to discuss second type of method, that is known as first derivative rule. Before this we have done without derivative. Now we are going to discuss with the help of derivative. Because the name of the chapter is application of derivative, it means we have to come at the point of by use of derivative. So we are coming about this. How can we apply here? We have to prove given function x cube minus 6x square plus 12x minus 18 is an strictly increasing function when x belongs to real number. So according to this rule, we have to take here first derivative by power come forward, power decrease by 1. 6x is power come forward, power decrease by 1. Derivative of x become 1 and derivative of it constant become 0. If you see here, 3 is common in all. So 3 is common, it is x square minus 4x plus 4. If you see here, it is a square of x, it is a square of 2, it become here 2ab. So it become here 3 times x minus 2 whole square by identity a square plus b square minus 2ab. If after first derivative, our first derivative comes out positive, then we say function is strictly increasing. This is by use of first derivative. As we see here, square of any number is always positive and 3 is also positive, so product of two number become always positive. If we get somewhere first derivative become less than 0, then it is known as strictly decreasing function. This is our rule to identify the function is strictly increasing or decreasing by use of first derivative rule. Now we are going to discuss how can we find out the intervals for the given function is given interval is increasing or decreasing. Let's see about this. Our next question is on how can we find out the interval on which the given function is increasing or decreasing. To find out the intervals, we have to use again first derivative rule. Here, first of all, we take first derivative of the given function. 5 derivative becomes 0. Here, 36 is derivative of x become 1. 3s is derivative of x cube become by power 2x. 2s is derivative of x cube become by power 3x here. Here, f dash x we get finally 36 plus 6x minus 6x square. To find out the interval, what we have required some points that are known as critical point, otherwise we can say here terminal points. To find out critical point or terminal points, for critical points, critical oblique we can say terminal points. We can say terminal point, otherwise critical point means the points on one side of the given function are increasing, on other side it may be decreasing, not showing the same characteristics on both sides. So these points are known as critical point, otherwise terminal point. How can we find out? To find out this, we have to take first derivative should be is equal to 0. If we take it is equal to 0, it becomes 36 plus 6x minus 6x square is equal to 0. If we cancel out by 6 with minus symbol, we get from here x square minus x minus 6. Now by separating middle term method, we get the factors like this. Minus 3 plus 2 are the factors. If you see here, from here value of x comes out 3, from here value of x comes out 2 with negative symbol. If you see on number line, there are 2 points minus 2 and plus 3. If you see here on the left hand side minus infinity, right side plus infinity. There are 3 partitions, one on the left hand side, one on the in between, one is on the right side of the given point. How can we identify? We are indicating here case first when x belongs to from minus infinity to minus 2. How can we check out? We have to see our first derivative. Here first derivative is given by this one. Here we cancel out minus 6. We are writing this one. It is given by minus 6 with x minus 3 x plus 2. We have to just check out the symbols only, not the accurate values. If you see values from here, these values should be less than minus 2. We are taking an example of minus 3 here. What is the effect on symbol? Minus 6 is already negative. If we put value less than minus 3, for example, we put here minus 3 and minus 3 become minus 6. So overall symbol become negative. If we put here minus 3 plus 2, it become minus 1. So overall answer become negative. So it is known as decreasing. If we come out on second case, x belongs to minus 2 to plus 3. First derivative symbol we have to check. Minus 6 is already negative. Minus 2 to plus 3, we are taking here minus 1. If we put here minus 1, minus 1 minus 3, minus 4. So overall negative. Minus 1 plus 2 plus 1. So overall symbol comes out positive. So it is increasing in this case. Now we are going to discuss about third. When x belongs to greater than 3 means 3 to infinity. We are taking the value greater than 3. Suppose we are taking here 4. Minus 6 is negative. If we use 4, 4 minus 3, 1, positive. 4 plus 2, 6, positive. Overall symbol comes out negative. So function is here decreasing. If we discuss on the interval, here the function is decreasing, increasing, decreasing. Most probably we get like this. If we get one of the interval is decreasing, next alternate should be increasing, next alternate should be again change, it comes out decreasing. It means the given function is increasing between minus 2 to 3 and decreasing from minus infinity to minus 2, union with 3 to infinity. Before this, we are discussing about algebraic function. Now we are going to discuss about exponential type of function. How can we identify it is an increasing or decreasing function for interval case? By using first derivative rule, we have to take first of all derivative. If we see here, it is a product of two functions. So by using product rule, first function remains same. Derivative of e raised to power is e raised to power. Derivative of power is minus 1. Plus second function remains same. Derivative of second function become here 1. If you see here, this function is common. So we take it common outside. From here minus 1 multiply this become minus x minus 2. From here it is plus 1. So overall we get from here e raised to power minus x with minus x minus 1. If we take here minus is common outside, we get final out this one. This is the value of function after first derivative. To find out critical point, for critical points, our rule is take first derivative as 0, means this value as 0. As you know, e raised to power cannot be 0. It is 0 when e raised to power is given by minus infinity, because e raised to power infinity is infinity and e raised to power minus infinity is 1 by e raised to power infinity, which is 1 by infinity means 0. So this value cannot be 0. If you take this value is equal to 0, value of x comes out minus 1. If you see on number line, for minus 1 we are having two cases. One should be right side, one should be left hand side. So we are discussing here case first when x belongs to minus infinity to minus 1, means left side of the critical point. If you see here, symbol of f dash x, due to minus symbol it is negative. E raised to power is always positive. Now if you put value of x less than minus 1, for example minus 2, minus 2 plus 1 gives us minus 1, overall negative sign. So overall symbol of this function become positive. So it is strictly increasing in first interval we choosing here x belongs to minus infinity to minus 1. Second case we are taking here, if x belongs to minus 1 to plus infinity, means right side of the critical point. If we see what type of symbol comes, due to this symbol negative, e raised to power is always positive. If we put greater than 1, suppose 2, greater than minus 1, suppose we choose closer to it, 0.9 with minus symbol. Minus 0.9 plus 1, which gives us 0.01 with positive sign. So overall symbol become positive. So overall function symbol become here negative. So the given function becomes strictly decreasing on the right side of critical point. Now we are going to discuss another type of function, that is logarithm function. Here we are taking example of logarithm function is trigonometric function. In this interval we have to prove it is a decreasing function, and this interval should be an increasing function. So we using first derivative rule. By take derivative of first function, logarithm is reciprocal of function. Then we take derivative of inner value. Derivative of cos theta is a minus sin theta. So overall become minus tan theta. If you see here, for x belongs to 0 to pi by 2, it means it should be first quadrant. In first quadrant, tangent of theta is always positive, but it is negative. So minus of tangent theta become negative, means first derivative become less than 0. So here function should be strictly decreasing. This is the first case. And second case, x belongs to pi by 2 to pi. Pi by 2, here pi means 180. 180 divided by 2, 90 to 180 means it lies in second quadrant. As we know, in second quadrant, sin theta and the reciprocal cosecant theta are positive, tangent theta are negative. So tangent theta is less than 0, negative of it become positive, means first derivative comes out positive in this interval. So at this interval, the given function is strictly increasing function. So like this, we can use testing of decreasing and increasing by first derivative rule for logarithm function. So we will continue. We are taking example of trigonometric function. Here function is given by sin x plus cos x. Our question is to find out the intervals on 0 to 2 pi in which the given function f of x is increasing or decreasing. Again we are moving to use of first derivative. By first derivative, derivative of sin theta is given by cos theta, and derivative of cos theta is minus sin theta. Next step is for critical point, we have to take first derivative should be 0. It means cos of x minus sin of x is equal to 0. It means cos of x should be equal to sin of x. As you know, cos theta, sin theta both are equal at 45 degree only. And if you see here, both the symbols are same and both are positive, either both are negative. It is possible only in first quadrant and third quadrant. So we can do also like this. If we divide by cos x on both sides, we get this one. Tangent theta is 1, it is at 45, we can say pi by 4. Tangent theta is positive in first quadrant, that is angle. In third quadrant, we have to reach third, we have to use pi plus pi by 4, means 180 plus theta. So value of x become from here pi by 4, otherwise 5 pi by 4. If you see on number line, starting from 0 to 2 pi, 360 we can say pi by 4 and 5 pi by 4. There are three intervals, 1, 2 and 3. So we are taking the value of angles on which we are known the value of function in table. From 0 to 45, case first, x belongs to 0 to pi by 4. We are taking here example of 30 degree because we know the value of 30 degree from table. F dash 30, 30 means pi by 6, cos 30 minus sin 30. Cos 30 from table, we know it is given by cube 3 by 2. It is 1.732. Sin 30 from table 1 by 2, which is approximately 0.5. So answer should be positive here. So in this interval, the given function is strictly increasing. Now we are going to discuss second case. In between these two critical points, from 45 to 225, we are taking here 180 because we know the value of 180. X belongs to pi by 4 to 5 pi by 4. We are taking here 180 means pi. Cos pi minus sin pi. Value of sin 180 is 0, cos 180 is minus 1. So overall minus 1 less than 0. Strictly decreasing function. Now we are going to discuss third type of interval greater than 225 but less than 360, where we are taking here 270. 5 pi by 4 to 360, we are taking here 270. 270 means 3 pi by 2. Cos 270, it is 0. And sine 270 is minus 1. So by using value, it becomes overall plus 1. Means first derivative comes out positive. So in this interval, given function is strictly increasing function. So like this, we can find out the intervals when the function is given as trigonometric function on the given interval. We can make here partition of the intervals. If we see here our observation, in first interval, it is increasing. Second decreasing, again it is an increasing. Means increasing, decreasing intervals are mostly alternatively to each other. If you like this video, so please like the video, share the video more and more, and please subscribe the channel to get the more updates from maths classes channel related to maths from your class, and you will get the knowledge about your topic and in a clear view. Thank you.